it's like...
Newton's laws.
Gotta push it.
Continued.
What's the force for?
We have a mass, 1.5 kilograms, sitting on the ground,
Just hit me.
just chilling.
Oh,
You apply a horizontal force, 3.75 newtons,
Weak.
when it starts to slide. So you've got that much when it starts to slide.
Yeah.
Determine the normal friction and forces and the coefficient of friction. So what's a great way to start this
F
one?
equals N times A.
Draw a picture. All right. What are the forces acting?
Normal.
Normal.
P.
Applied.
Oh.
So since it doesn't have other state, it would graded
I don't know. I don't know what it is.
We sum the
Forces.
J's.
Yeah. That's right.
Sum the J's. So we have, if that's the positive J direction, what's positive? And what's negative? Alright, so N equals W, because the net force is 0.
Therefore,
So what's W? Newton's law.
Alright, F equals M times A.
Mass times acceleration.
Which is 1.5 times 9.8. I got this one, so
14.71.
you can...
What's the one next? Friction. So what do we do? Sum the I's. Sum up the I direction. So because it's net force, they all add to 0. What's going in the I direction? Applied, thank you, and the
Friction.
so applied equals friction. What's the applied force?
3.75 newtons.
So we're all done.
Amazing.
Next one, coefficient of friction. How do we do that?
U.
Friction force equals mu times law.
Yep. So we've got the friction. We've got the normal. So mu equals 3.75 divided by 14.7. The newtons cancel out because mu has no units, in case you didn't know that. So into your calculator. So we have
How many units of labor are expelled?
any questions? Another way to do it is like this: n minus w j plus a minus f I. Okay? R equals 0 because it's just beginning to slide when you apply. Did for the last
Draw a
example.
picture.
Let's draw another picture.
Mr. Hayward ski.
What sort of name is that?
We've got friction. We've got normal, which acts perpendicular to the plane. And we have W. So if this is the 5 degrees, because of our triangle rules,
The one on the left is the one.
using trigonometry.
Ah,
So this is the adjacent. So it is W
on
cos theta. This one's the opposite. So this is W.
sine
So this arrow here
theta.
Applied.
is going this way. So we've got W sine theta. We've got one that's the opposite direction of normal. W
What would that
cos.
force
It doesn't actually matter.
Parallel.
35 degrees from the...
As long as it's parallel, you can either do it down or up, as long as you do it correct in your sum, okay? So the I's, we have, Okay, so we're summing it all, and all of the forces equal the resultant.
Yeah, okay,
Because it's not beginning to slide, it's already, it's a slope higher. Yeah? Does it make sense now?
Yeah.
Okay, cool.
83.
So if you type something in and click equals in OneNote, it tells you the answer.
That's so.
There you go, Mr. Hayward's top tip for this video.
Like green doesn't.
Well, let's try subbing in everything.
Oh!
So we know the mass is 85. Where do we get the acceleration for r from?
Can you calculate from the velocity that you
Yep.
Differentiate.
Okay.
Oh, no.
So we have 42 meters during the first 10 seconds. So you know, it says in the question the acceleration is constant. In the previous weeks, I said make that n.
Integrate.
V equals nt plus c. He starts at what?
Rest.
So c equals.
0.
So when t equals 0, r equals, v equals 0.
doing just slower.
All right?
Yeah.
And then we know r equals nt squared over 2
Yeah.
plus c2.
Yeah. And C2 equals 0.
C2 also equals 0.
C2 equals 0.
And substitute, sir.
So we have 42 meters during the first 10 seconds.
So substitute 10.
So 42, when t equals 10, r equals 42, n times 10 squared divided by 2. Does this make sense?
Yeah.
Isolate n to find the acceleration.
84.
That's incredible.
Is that okay? So we found r by integrating, and then we found, that's like the general equation for r. We then found the specific r 42 when t equals 10, so we could find the constant acceleration, which is 0.84. So we can now put this in to our equation. Then we sum the i's.
Oh, yes, right.
So we have, I should have figured that out first. Sine 5. Yesterday I was like, oh yeah, and I did it all and I was like, makes sense, and now I forgot it. Things to note. You get a question like this, you need to note that it doesn't talk about just beginning to slide. So that's kind of a key, that it's not summing to 0, it's summing to mass times acceleration. So it's different to the other types of questions, where usually it's summing to 0. Yeah?
But it's
That's the thing to note. So you need to find the acceleration to find the resultant. Okay? And then you times it by the maths.